Hi, fourth graders. This is Miss Ellis, and today I am going to teach you lesson 613. Today, students will use their understanding of whole number multiplication to multiply fractions by whole numbers. Okay, remember the first thing we want to do is our mental math. I know that your slates are in school, so for mental math, you can use a piece of paper and a pencil. Remember, mental math is supposed to be pretty quick. It's supposed to be something we can do in our heads. We want to write down our answers to keep track of our thinking. Okay, so for our first slide, you're going to add and subtract fractions on your slates. In this case, it's going to be a piece of paper that you have and a pencil. Okay, so the first equation I want you to do is 1/4 plus 2/4 equals blank. Okay, remember when we add fractions, we have to have the same denominator. The next one, 5/8 plus 2/8 equals blank. And you can choose to write down the whole equation or just the answer. For the third one, 7/10 minus 4/10 equals blank. And the fourth equation, 5/6 minus 1/6 equals blank. All right, I hope you wrote down your answers. Let's check them out. 1/4 plus 2/4 equals 3/4. 1 plus 2 equals 3, and then we leave our denominator the same. 5/8 plus 2/8 equals 7/8. 5 plus 2 equals 7. We keep our denominator the same. 7/10 minus 4/10 equals 3/10. 7 minus 4 equals 3. We keep our denominator the same. 5/6 minus 1/6 equals 4/6. 5 minus 1 is 4, and we keep our denominator the same. Okay, that was pretty easy. Let's move on to our second slide where the work gets a little harder. 2/3 plus 2/3 equals blank. Write down your equation or just the answer. 9/12 plus 1/12 equals blank. 8/4 minus 3/4 equals blank. And 1/2 minus 4/5 equals blank. All right, I hope you wrote your answers down. Remember how important mental math is to warm up our brains for a math lesson. All right, let's check out the answers. 2/3 plus 2/3 equals 4/3, which is equivalent to 1 and 1/3. 9/12 plus 1/12 equals 10/12. 9 plus 1 is 10. We keep the 12. 8/4 minus 3/4 equals 5/4, which is equivalent to 1 and 1/4. And 1/2 minus 4/5 equals 1/5. Remember, we look at this denominator to figure out what a whole is. So in this case, 1, grab my pen, is the same as 5/5. So 5/5 minus 4/5 equals 1/5. All right, let's go on to the hardest mental math slide. 1 and 3/5 plus 2 and 1/5 equals blank. 4/10 plus 3/100 equals blank. Give you some time. 2 and 1/4 minus 2/4 equals blank. And 33/100 minus 3/100 equals blank. Okay, take a minute to figure those out. All right, let's look at the answers. 1 and 3/5 plus 2 and 1/5 equals 3 and 4/5. Remember, we're going to add the wholes. So 1 plus 2 is 3. Then we're going to add the fractions. 3/5 plus 1/5. 3 plus 1 is 4. We keep that denominator of 5. 4/10 plus 3/100. I look at this and I say, uh-oh, my denominators are not the same. And for addition and subtraction, I need them to be the same for me to either add or subtract. So I'm going to multiply, let me grab my pen. the top and bottom always by the same number. So I'm going to multiply the top and bottom by 10. I know that's hard to see, I apologize, because I want this fraction to have a denominator of 100, so they match. So I'm going to multiply the top and bottom by 10, so it's going to be 40 hundredths plus 3 hundredths equals to 43 hundredths. Okay, this is the next one, 2 1/4 minus 2 fourths equals 7 fourths. For this one, I'm going to change my mixed number into an equivalent fraction with my little trick. I'm going to multiply. 4 times 2 is 8, plus 1 is 9. 9 fourths minus 2 fourths equals 7 fourths, which is equivalent to 1 3/4. And then here, 33 100ths minus 3 hundredths. I see these denominators are the same, so I know I have the green light to subtract. 33 minus 3 is 30 hundredths, which is equivalent to 3 tenths. All right, let's move on to our math message. Draw a picture and write an equation on your slate to represent the following number story. There are 3 vases. Each vase has 4 flowers in it. How many flowers are there in all? Okay, so let's try to imagine this in our heads. There are 3 vases. Remember, vases are what holds flowers. Each vase has 4 flowers in it. How many flowers are there in all? Okay, so what I would do, everyone knows, at least in my class, that I'm definitely not an artist. So I would just draw 3 circles to represent my vases. I would draw 4 X's to represent my flowers in each one. So, 3 groups of 4. And then I would count how many flowers are there in all. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 flowers. So the possible equations we can have to solve this number story, 3 times 4 equals 12, or we could use addition. Remember, we said there are 3 groups of 4, so 4 plus 4 plus 4 equals 12. Here's a beautiful picture that does not look like mine at all, but represents the same thing. So there are 3 vases. They each hold 4 flowers, and if I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, I will find that there are 12 flowers. So remember that these equations are equivalent. Whether I do 3 times 4 or 4 plus 4 plus 4, I'm going to get the same answer of 12. All right, let's try another problem. Cut flowers will stay fresh longer if 1/4 cup of soda is added to a vase full of water. If a florist has 3 vases of flowers, how much soda is needed to keep them fresh? Okay, so these are the questions we want to think about. How would you represent the problem with words? How can you write an addition equation to represent the problem? And then in the math message, we determined 4 plus 4 plus 4 and 3 times 4 both represent 3 groups of 4. So can you write a multiplication equation to represent 3 groups of 1/4? So I basically want to know, how can we write this problem in words? How can we write it as an addition equation? And how can we write it as a multiplication equation? Okay, take a minute to think about that. All right, let's check our answers. So how can we say this in words? If it's 1/4 cup of soda in each vase, and there are 3 vases, that's the same thing of saying 3 groups of 1/4. How can we write this as an addition equation? 1/4 plus 1/4 plus 1/4 equals 3/4. In the math message, we determined 4 plus 4 plus 4 and 3 times 4 both represent 3 groups of 4. So how can we write our multiplication equation here, our addition equation here, excuse me, as a multiplication equation? So 1/4 plus 1/4 plus 1/4 equals 3/4 is the same thing as saying 3 times 1/4 equals 3/4. 1/4 plus 1/4 plus 1/4 and 3 times 1/4 are equivalent expressions in the same way that 4 plus 4 plus 4 and 3 times 4 are equivalent expressions. So let's look at our picture. 1/4 plus 1/4 plus 1/4 equals 3/4. Okay, or we can use fraction circles. This represents 1/4, 1/4, 1/4. If we put the fraction circles together, it equals 3/4. So what I like to do for addition is I like to think of the whole number 3 if I'm doing this equation. What I like to do for multiplication okay, I have 3 times 1/4 equals 3/4. I like to think of 3 as 3 times 1. And unlike addition and subtraction with fractions, when you are multiplying fractions, they do not need to have the same denominator. So you're just going to multiply right across. 3 times 1 is 3. 1 times 4 is 4. So this equals 3/4. Okay, while we're early in multiplying fractions, a picture is great to represent your thinking. Okay, but this is how I think of it, 3/1 times 1/4, and we're just multiplying right across. Okay, next. A florist has 5 bunches of daisies she wants to dye blue. For a few hours, the stems of each bunch need to sit in a mix of 1 cup of warm water and 3/8 teaspoons of food coloring. How many cups of water does the florist need in all? I have the answer for you over here. How many teaspoons of food coloring does the florist need in all? So how did I figure out how many cups the florist needed? Well, she has 5 bunches of daisies, and they have to sit in 1 cup of water. So that would be 1 cup plus 1 cup plus 1 cup plus 1 cup plus 1 cup equals 5 cups. So it would be 5 groups of 1 cup. And then how many teaspoons of food coloring does the florist need in all? This really should go over here. So we could say, remember, there are 2 separate problems. How many cups of water and how many teaspoons of food coloring? 3/8 plus 3/8 plus 3/8 plus 3/8 plus 3/8. And that's going to tell us how many teaspoons of food coloring the florist needs. Now, it's kind of difficult for me to write with my pen, so let's move on to the next slide to answer these problems. Think about, how would you represent the problem with words? How can you write addition equations to represent the problems? We figure that out here. How can you write multiplication equations to present the problems? So remember, there's going to be a multiplication equation that's equivalent to this problem, and a separate multiplication equation that's equivalent to this problem. Between what 2 whole numbers does the total amount of food coloring need to lie? All right, so let's move to the next slide. So we could think about the water as 5 groups of 1 because there's 5 bunches and it's each 1 cup. And then we could think about the food coloring as 5 groups of 3/8 because there are 5 bunches of daisies and each bunch needs 3/8 teaspoons of food coloring. How can we write addition equations? 1 plus 1 plus 1 plus 1 equals 5. That's for the water. And then the food coloring is 3/8 plus 3/8 plus 3/8 plus 3/8 plus 3/8 equals 15/8 because 3 plus 3 plus 3 plus 3 plus 3 equals 15. And then when we're adding, we leave the denominator the same, so 15/8, which is the same as saying 1 7/8. And remember, I figure out 1 7/8 because I say, how many times does 8 go into 15? Just once, and then there's 7/8 left over. Can you write multiplication equations to present the problems? So 5 times 1 equals 5 is the same as saying 5 groups of 1, or 1 plus 1 plus 1 plus 1 plus 1 equals 5. 5 times 3/8 equals 15/8, which equals 1 7/8, is the same as saying 3/8 plus 3/8 plus 3/8 plus 3/8 plus 3/8 equals 15/8. Remember my little trick? I like to think of 5 as 5 over 1. And then I'm just going to multiply straight across. 5 times 3 is 15. 8 times 1 equals 8, right? Because remember, in addition, and subtraction, I need my denominator be the same, but multiplication, I can just go straight across. Okay, and then I say, how many times does 8 go into 15? Just once, because 8 times 1 is 8, and then I have 7 left over, and 7/8. So 1 7/8, between what two whole numbers does the total amount of food coloring need to lie? 1 7/8 is between 1 and 2. It's not quite 2, it's 1/8 away from being 2 wholes, but it's between the whole numbers 1 and 2. Okay, and here is a lovely picture that we can use to represent both the cups of water and the food coloring. So it's 5 bunches of daisies. Each bunch gets 1 cup of water, so we can see that they have 5 cups. Each bunch gets 3/8 teaspoons of dye. So 3/8, 3/8, 3/8, 3/8, 3/8, and then we can just add them up for a total of 5 cups and 15/8. Okay? And then you could think of it with fraction circles as well. So this is 3/8 plus 3/8 plus 3/8 plus 3/8 plus 3/8. We put it together, we get 15/8. All right, so this is it for my lesson. I am also going to put up the PowerPoint slide so you can go back, you can review, you can kind of test yourself and go at your own pace. And there are also 3 videos you can check out if you want a little more clarification. The first video is multiplying fractions by whole numbers using fraction circles. The second video is multiplying fractions by whole numbers by drawing pictures. And the third one is multiplying fractions by whole numbers using a number line. So make sure to check those videos out. After you review all the materials from the lesson today, please do one of your worksheets, and then remember to submit the exit ticket for 6/13 when you are finished with the lesson. It's great to do it the day that it's due because the lesson is fresh in your head. All right, thank you, 4th graders. Please let me, Mrs. Kempton, Mrs. Coe, know if you have any questions. You guys are doing a great job, and I'll see you for the next lesson. Bye.